sklearndecompositionNMF. Input 1. Explain in detail a non-negative data matrix, where each row represents a sample and each column represents a feature. For example, in a document term matrix, each row would represent a document and each column would represent a word. The number of components to extract. This parameter controls the dimensionality of the reduced representation of the data. A non-negative matrix W, also known as the feature matrix or basis matrix. Each column of W represents a basis vector, and each row of W represents the contribution of each basis vector to the corresponding sample. A non-negative matrix H, also known as the coefficient matrix or mixture matrix. Each row of H represents the contribution of each basis vector to the corresponding sample. Step 1. Explain in detail. NMF initializes W and H with random non-negative values. NMF iteratively updates W and H using an optimization algorithm that minimizes the Frobenius norm of the difference between the original data matrix and the product of W and H. This process continues until convergence, which means that the difference between the original data matrix and the product of W and H is below a predefined threshold. Metric 1. Explain in detail reconstruction error. This metric measures the difference between the original data matrix and the reconstructed data matrix, the product of W and H. It is used to evaluate the quality of the decomposition. Sparsity. NMF encourages sparsity in the W and H matrices. Sparsity means that most of the entries in these matrices are zero. This property can be helpful for interpretability, as it allows us to identify the most important features and their contributions to the samples. Visualization. Plot 1. Explain in detail heat maps of W and H matrices. These plots allow us to visualize the basis vectors and their contributions to the samples. Scatter plots of the reduced data. These plots allow us to visualize the relationships between the samples in the reduced space. N components. This parameter controls the number of components to extract. Higher values of N components can capture more complex relationships in the data, but may also lead to overfitting. In it, this parameter specifies how to initialize W and H. Common options include random, NNDSVDA, and NNDSVD, which use different methods to initialize the matrices. Bootstrapping. This method involves resampling the original data matrix multiple times and then performing NMF on each resampled dataset. The resulting W and H matrices can then be used to estimate the uncertainty in the decomposition. Bayesian NMF. This approach uses Bayesian inference to estimate the distribution of the W and H matrices. This allows us to quantify the uncertainty in the decomposition. Local minima. The NMF algorithm can get stuck in local minima, which means that it may not find the optimal decomposition. This can happen if the initialization of W and H is poor or if the optimization algorithm does not have enough time to converge. Try different initialization methods, use different optimization algorithms, or increase the number of iterations. Interpretability. The interpretation of the basis vectors and their contributions to the samples can be challenging, especially for large datasets. For example, in a document term matrix, it can be difficult to understand what each basis vector represents. Use visualization techniques such as heat maps and scatter plots to help interpret the results. Use domain knowledge to help understand the basis vectors.